Greetings, ma'am. My name is Lahari B K. Today, we'll be presenting our project titled Dolphin Echolocation Optimization Acoustic Intelligence in Marine Navigation. Dolphins have a nature sonar ability that emits high frequency clicks and convert returning echoes into a detailed 3D mental maps of their surroundings. This allows them to detect objects over 200 meters away, track their movement, and navigate even in noisy underground environments. Our project studies how these biological principles, like adaptive frequency control, beam steering, and noise filtering, can inspire smarter underwater robotics, autonomous vehicles, and sonar systems. Now, let me quickly explain the flowchart. We start by initializing a population of dolphins with parameters such as pulse, rate, and radius. Each dolphin's fitness is evaluated based on the echo it receives, similar to how real dolphins judge distance and object clarity. We then identify the best dolphin, which represents the best current solution. Next, each dolphin emits new sonar pulses and generates candidate solutions based on echolocation probability. If a newly generated solution is better, we update the global best. Else, this loop continues until the maximum number of iterations are reached. Finally, the algorithm outputs the best dolphin, which represents the optimized solution. This is exactly how the algorithm works. Next, I would like to hand over this to Pooja.
I'll be explaining dolphin echolocation cycle. Dolphins use sound like natural sonar system. One full echolocation cycle includes 6 steps, repeated many times per second. First step is click production, where dolphin generates rapid high frequency clicks. The purpose of this is to start scanning the environment. The second step being beam focusing. The fat-filled organ called the melon focuses the sound into narrow beam. So this points the sound beam towards a specific target. The third step being sound propagation through water. The focused sound beam travels through water, and high frequency is good at detecting small objects, while low frequency is good for detecting long distances. The purpose of this is to send energy outward to hit objects. The fourth step being target reflection. When the sound hits an object, it bounces back as an echo. The fifth step is echoes reception through jaw. Dolphins receive echoes primarily through their lower jaw. Signals go to the brain for processing. The sixth and the last step is brain analysis and mental 3D mapping. The dolphin's auditory cortex does ultra fast processing. To understand what the object is and where it is, this step is important, and then it comes back to the optimized next click. Neuroacoustic process. Dolphins use their brain to read echoes. They quickly calculate distance, check if something is moving, and also compare echo strength, and even tell what the object type is made of. Now, the mathematical terms. They find the distance using distance is equal to speed of sound into time delayed divided by 2. High frequency sound finds small targets, low frequency reaches far. They reduce noise and focus their sound beam to get their clear picture. Lastly, I would like to conclude by stating the key features. So basically, this echolocation is how dolphins see using sound. They make the clicking noises, and the echoes that return help them create a mental 3D picture of the world, including the distance, shape, material, and movement of any object. So they can even detect objects 2 meters away from that and tell whether it is metal or a plastic, and identify whether something is hollow or solid. So these natural abilities inspire advanced human technologies. For example, underwater robots and autonomous vehicles use dolphin-like sonar for navigation. Military and civilian sonar systems also copy these principles for better ocean scanning. Even medical ultrasound imaging uses the same concept. So dolphins use several intelligent optimization tricks. They change their click rate depending on how clear the target is, adjust the sound frequency for better detail. So they steer their sound beam like a torch to focus on specific objects and filter out the background ocean noise. So keeping only the important signals. So overall, dolphin echolocation shows how nature acoustic intelligence can help us build smarter marine navigation and advanced sound-based technologies. Thank you.